some additional methods which are often useful, namely wait and notify. In addition to the entry set, there is also a wait set. And the purpose of this wait set is for a thread that has taken the lock but discovers that it's not useful yet and some other thread needs to fix it. Then this thread, which currently owns the lock, can call wait. This releases the lock and blocks the thread and puts the thread in this wait set. So this thread is not trying to get the lock back. Some other thread may take the lock instead and then hopefully fix the object. So when another thread then has done something useful to this object, it can call notify, and it will wake up one of the threads in the wait set. And what happens then is that it is put into the entry set, meaning that it will possibly get the lock next. Okay, calling notify does not release the lock. And we can also call notify all, which wakes up all of the threads and puts them into the entry set. So one more detail, and a Java object lock is a so-called recursive lock. There is not much recursion in this, but this is the standard term, and it means that you can take a lock that you already have. And of course this could be used for recursive functions, but typically it's used for different synchronized method of the same object. And this name was introduced long before Java was introduced. A pthreads lock is by default not recursive. You have to specify that it should be a recursive lock. So what does it mean that the lock is recursive? Well, it means that there is a counter so that when the owner of the lock takes it, so to speak, another time, this counter is incremented, and when it unlocks it, the counter is decremented, and the lock is really unlocked when the counter is 0, obviously. Okay. So when a thread is waiting, it can be interrupted using the method interrupt, and therefore the wait should be done in a try, wait and catch block. This will not be needed in this course, and we will not talk about it. I mean this interrupt method more. Okay, sometimes it's not sufficiently convenient to use the implicit locks of an object. Instead, we may want to use like a more normal lock, and it can be, we can for instance use this reentrant lock, and with it we can we create it with this after importing the declarations here, and then we just use a lock or unlock. We can also do something called try lock and then unlock. Try lock returns true if the thread got the lock, and false otherwise. So this can be used to check if this lock was free. And why would you want to use a try lock? Well, if you have a program and you cannot figure out if an efficient and simple rule for enforcing a lock order, then this may be useful. Okay, so the lock order, recall, it is used for avoiding deadlocks. Say we have these two nodes U and V, and if all threads take them in the same order, then there can be no deadlock. But if one takes it first U and the other V, okay, by U and V I mean the real objects, not the variables that, I mean, they are, for one thread U may be one object, and for another thread V may be the same object as U for the other. But obviously what I mean is that if two threads want to take the locks of two different objects and then do that in the opposite order, then there is a deadlock. And if you can figure out a way so that all threads always try to get the locks in the same order, there can be no circular wait, because if one got the lock, the other has to take the same lock first, so it cannot have taken the other lock. Okay. If you cannot figure out such a rule, which may be impossible if the nodes are more or less random, then it can be useful to use try-lock. So say you want to take 10 objects. You can then do try-lock for each of these and continue until you have taken all the 10 objects. And if you fail, you start all over. Okay, so try-lock can be useful, but it's since it's a speculative operation, it is not so nice to start with. I mean, it's better to use a strict order if that is possible. Okay, and for lab 2, it is quite easy to figure out such a rule to avoid having to use try-lock.